Hello and welcome to Math Lessons with Linda. Today's topic is how to solve a 3x3 system of equations. If you have not yet watched any videos or had any lessons on solving a 2x2 system of equations, stop this video, go back and watch that first. Otherwise, let's go. So here are our three equations. 3x plus y minus z equals 4. X plus 2y plus 2z equals 5. 4x plus y minus z equals 3. So it's called a 3x3. There are three equations and there are three variables. We need to solve for all of those. In a 3x3 system of equations, you cannot use substitution. You have to use elimination, and you can only substitute back once you have found the first value of whichever variable you've solved for. So the way we're going to do this is we are going to choose which variable we want to eliminate, and then we're going to choose which two equations we'd like to start with first. So I'm going to start with the first two equations, and I want to eliminate the z. So I have a minus z and a plus 2z here. So the first thing I'm going to do is take my first equation up here and multiply it through by a 2. So I'll get 6x plus 2y minus 2z equals 8. And I'm going to keep the second equation the same. So when I go back and I want to add up my equations, notice that I have opposites for the z's, and I get a 7x plus 4y equals 13. So I'm going to start this equation. I'm going to need it again in a little bit, but now I need to go back to my original three equations, and I need to choose a different combination of two equations, but still getting rid of my z variable. So what I'm going to do is I'm going to choose my first equation again, and I'm going to use the third equation because they both have minus z. So if I multiply this top equation by -1, it'll change the sign and I will be able to get rid of the z's once again. So this gives me -3x minus y plus z equals -4. And then I'm keeping my last equation the same. I don't need to multiply by that because these z's are now going to cancel each other out. So what also happens on here is notice that when we did that, these y's are also going to cancel out. That's lucky for us. It saves us a step in this problem. So now I get a 1x. Over here, I get equals -1. And so I already have one of my values for my system. So this equation that we started a moment ago, I'm going to plug in this -1 because now I can immediately solve for my y. So I have 7 times -1 plus 4y is equal to 13. So this is -7 plus 4y equals 13. I'm going to add the 7 over. So I'm going to get 20. And my y value will equal to 5. So my last step is I just need to solve for the z, and you can choose any of the three original equations. I think I'm going to choose this last one down here. So 4 times -1 plus the y, which is my 5, minus z equals 3. So I'm going to do a little bit in my head since I'm running out of space. I have a -4 plus 5, so that gives me a 1, minus z equals 3. And I'm going to move this one over here. I get -z equals 2, but I need to have a positive z. I'll divide both sides by -1. So I get z equals -2. Now, when we're solving a 2x2, it's an ordered pair. This time I write my answer as an ordered triple, and we write them alphabetically, so it's my x, my y, and my z, and that's how I solve a 3x3 system of equations.